Hello, this is a short video to showcase my final project or my honours project for Plymouth University. This project is called Project Getaway. It's basically a procedurally generated getaway driver game with the emphasis being on the procedural generation. Basically, I wanted to take a game that I used to play when I was a lot younger, from 1999 and the early 2000s, called Driver, and try and recreate it, but create a procedurally generated tile environment that would guarantee the player an escape route. So it generates a start point, an exit point, and a guaranteed path of escape, and then populates the map around that. We'll showcase that a bit more in a moment. So let's get into the game so I can explain it a little bit better. To begin with, I've designed the simple UI. I wanted to give it a sort of a bank heist planning look, similar to the Italian Job or any bank heist movie you may have seen. So simply just a chalkboard effect in the background. That's a third-party asset that was taken. The text, the font, is another third-party asset. All of which just gives the general look and feel of a bank heist being planned, the escape route. We have a simple vehicle select option down here in the bottom left hand corner. This just gives an element of variety for the player. The vehicles are third party assets, but this actual outline was designed by myself, and a simple descriptor next to it. We've got some buttons that can be navigated through. A simple options button. I wanted to showcase and credit the individuals whose assets have been used to make the game. So there's a simple credit option there, and also a simple controls showcase, just so we can get an idea of what to use. The game would be compatible with controller in the future, but for the moment I've simply stuck to mouse, just a keyboard, just so I can simplify the controls. Seems the controls wasn't exactly what I was going for. Now, being that this is a procedurally generated game, I wanted to we need to ensure that we can prove procedural generation. This is possible by having a seed system. So what I want to do is I'm going to load up a level that I've got a picture of, so we can actually compare later on. Okay, so we load into the game. Let's just have a quick pause so I can show you the actual map assets and talk through how it was actually generated. So if we zoom out, this is the map. So we've got it's randomly generated between 25 and 50 units in width and 25 and 50 units in height, but always odd. The reason that I've done it always odd is to ensure that there is always a center point that is equal in distance from the edge. The edges either vertically or horizontally. What happens to begin with, the game will generate the start point, which is the section just here, the end point, and then build the path from that. The way it does that is this grid, the 25 or 25 to 50, however width or size it is. We can actually check that. It's 39 by 39 on this one. So a bunch of grid points are generated within one tile space. Then those points act as these sort of vector locations for instantiation of the map later on. So finding the center point, that point is generated automatically because it will always be in the center. The exit point is then taking us to one aspect of the edge. It cannot be the corners, it has to be within the section. The reason behind this was I didn't want any roads going off to the edge, which would add another vector of escape, basically. Then the tiles are populated along the route to ensure that there is a escape route at all times for the player. Then the rest of the map is generated. Now what I'm going to do is I'm going to go through line by line and just sort of explain each section. So we instantiate the start point just up here. So we instantiate that. It's always at half of the width of the level. So it should always theoretically be in the center. Then we need to instantiate the exit point. Now the exit point is anywhere around the edge, without it being in the corners. So we've got the methods just down here to ensure that. Depending on the random number that's generated, it ensures that case is activated. So top, bottom, left or right become 1, 2, 3 or 4 on the random generation, and then the exit point is instantiated at that section. To ensure that the road generation, goes to the correct point, I've created a pre-exit. So it's just a tile just in front of the exit point, so that we ensure we're not going into the edges. It was just simpler in terms of the algorithm to put that in place. Now, the key part is the escape route. We have to ensure there is an escape route at all times. Now, this is done by instantiating the tile asset via a quick check. So we go to choose next tile. Here, the current location, so starting from the start point, is passed through to this method. The north, south, east, and west points are taken based off of this location that's passed through. So we know these locations. We then loop through, and whichever one of these locations is the closest to the exit point, dependent versus the current tile, and it's not on the edge, because we need to ensure that it's not on the outer points, becomes the chosen tile. Now that means that the tile will instantiate at that point. Then it's added to a list just so we can store the object. Then the current tile becomes that, and we loop through until we find the exit. That's the way we guarantee that the road is generated in the method we need to. At first, it's only a tile that's put in place, not the actual road. That comes later on. We'll go through that in just a moment. Next, we need to populate the rest of the map. Now, the rest of the map is populated by looping through based off of the location. Let me find the correct point. Build map, just here. Okay, so what happens is we loop through until we find all of the objects within our map. Now those objects in the map, the size of this is dependent on the size of the grid. So this will always be the exact length we need to for all of the tiles to be generated within the map. Then we check to see the location of that grid point. Now if that grid point falls into the position of where the start point is, or the exit point is, we just continue because we've already generated those. We don't need to regenerate them. Else, if it's in one of the edge points, so the very height of it, the bottom of it, the left of it, or the right of it, so the outer edges, we generate just a simple instantiated map, which is pre-built. It acts as a blocker. For anything else, we then go through the process of taking that location and going through a decision matrix. Now, what I wanted to do is create sort of park elements within the game. So to create those, we have to do a check to make sure that the element can be a park. If it can't be a park, we need to say, no, you definitely can't be a park. That way we can guarantee that the park can't be generated and it will simply be a road. Then, dependent on the result of just up here, if it hits a certain part on the animation curve, which if we go back to Unity, we can see our animation curve just here. Let me drag that in. So this is our animation curve. The point at where the random number generates defines the point at which we check on here. And if this element is within our boundaries, which we've cast as 0.3, I believe. Where am I? Yep, 0.3. It will instantiate a park tile. If not, it will make it a road tile. So this is how we end up with these scenarios. If we switch this around, we would get a different element. So the park there'd be a lot more green on there. It'd be a lot more broken up, which we can showcase in the actual live demo in the presentation. Now that decision's been made, if it's a park tile, it will simply generate the park tile. If it's not a park tile and it is actually a road, it will instantiate that road into the spot. So either way, it will generate the correct tile that needs to go into the correct spot, basically. Once that's complete, we need then to go through and check every single tile to build the roads. Now, this was the most complicated element, in my opinion, in the entire map, the entire procedural generation. This was really I really struggled to actually get my head around the possible scenarios for this, but I managed to get there in the end. I've put in a simple waiting enumerator just to ensure that I can wait a couple of seconds, or 0.2f of a second, just to ensure that the rest of the tiles have been generated, because I don't want the roads to be built until the tiles are in place. And what I found in testing was that the tiles I was getting a lot of null references because the roads was trying to generate before the tiles were even built. So what we do is we go through, and for each north, south, east or west element of the tile in question, we check to see if it has a possible point where the road can connect. If it does, we set it to true, meaning that the road tile on this tile can have a exit point west, exit point north, depending on what the scenario is. Then, following that decision, we can then go through and select the correct road piece for the scenario. So in this instance, if the north is true and the east is true and south and west are false, then we will generate a corner piece, and the corner piece will be set in a specific direction. We have to do that for every single corner piece. And we continue this until we decide every element of the tiles. What we can see is the fluid nature of which the road builds. As I said, this was very difficult for me to get my head around, but once I did, I think it's delivered a fantastic result. Now, what we can see is this is the road that's generated using seed -8624. This is listed over here just so I can see it. And also in game, if we go into game and we get up the pause menu, we can see that's the seed number that's been done. So that proves that the procedural generation is there. Now what I need to do is prove that that is something that was generated before. So what I've done is I've taken a picture of the procedural generation with -8624. I'll just move this around so I can prove it's a picture. So you can see the -8624, and this is the exact layout. You can do a like-for-like comparison of the two. So we can see it's not very clear, unfortunately, but you can see that the road decisions have been made the same. The tile decisions look like they've been made the same as well. This proves that it's procedurally generated elements. So this has been a brief description of the actual procedural generator and how it's done. Now I'll go into it in more depth in the actual presentation with us, so we can go through and I'll showcase some different elements of the game. But thank you for your time. Sorry I can't go into more detail. I just want to keep this section short. Okay, thank you.